Picking up on the last video where we talked about logic gate combinations, we now want to introduce the sum of products, the product of sums, and then minterms or maxterms. So the sum of products is kind of exactly what it sounds like. It is when a function is given by a sum of individual contributions, and each of those contributions are a product. Inversely, we have the product of sums, where we have a product function here given by these three terms in parentheses. And sometimes you may be asked to expand a function in terms of the sum of products or the product of sums. So nothing too complex there. But now we want to introduce minterms and maxterms. Now the function we're going to be looking at is given here, where it's simply equal to a times b plus a bar times b bar. And we're going to start off by drawing a truth table where we have all of our inputs for a and b. And we're just going to label a numeric value to each of those inputs. Nothing special there. And from the original function, we can correlate this ab to a 1, 1 and this a bar, b bar to a 0, 0. And we know that these values for f are going to be where the 1s take place. So we put a 1 for the combination of 0, 0 and 1, 1, and the rest are zeros. But now we're going to introduce a term with a lowercase m and a subscript I, and that's going to represent your minterms. And we're simply going to denote I with each of these numerical values here on the left. So we have m0 all the way to m3. So what we can do here is simply just plug in these m values for what f is given by. Or another way to write this is f is equal to the sum of m0 comma m3. And this is just another notation for expressing this function f, just another tool to add to the toolbox. So what we can do next is look at the inverse of f. So we're just going to flip all these values from f. Now what we know is that the inverse of some variable where it has already been inversed is going to be equal to that original variable. We can expand that using De Morgan's law to say that f is equal to a bar plus b times a plus b bar. So now we've got two expressions for f. The first, which is a sum of products, and the second, which is a product of sums. Now the sum of products we could relate back to these min values, but for the product of sums, we're actually going to relate those to some max values given by a capital M. Now the max values are going to be equal to the inverse of the min values. And from this table, what you can see is that for the product of sums, our values fall in line with M1 and M2. So if we look at our minterms and our maxterms and look at f, we can express f as the sum of minterms, or we can express it as the product of maxterms. And these are two conventions you may be asked to express a function in. And I remember when I was an undergrad, it was a little bit tricky because you look at these maxterms and you see that they seem to correlate to f inverse. But if you actually take this product of sums and expand it out, what you get is a bar times a plus ab plus a bar b bar plus b bar. You'll see that these terms go to 0 and you get your original terms back. So that's how we can express a function in terms of the sum of minterms or the product of maxterms. Now we're going to look at an example where we start to use everything that we've learned and we imply some tricks. And to do that, we want to expand the function f equal to a b bar plus c as a sum of minterms. Now there's a few things you could do to look at this function, but it's time for shortcuts. And looking at this first function, if we expand that, we would get a b bar c plus a b bar c bar. So we know that this would correspond to 1, 0, 1, and 1, 0, 0. So we know we're going to have a 1 here and a 1 here. But let's intuitively look at this part of the function, ab bar. Notice that there is no c here right now. And from this, we can take away that the function does not care what C is if we have a B bar. No matter what C is, we're going to get a 1, as you can see from here. So what we can do is look at the truth table and simply look when A is 1 and B is 0. And look here, we get our 1s. Now if we look at the second part, C, you can see that the function doesn't care what A and B are. They don't even matter. As long as C is equal to 1, then we're going to get a 1. So we can fill in the rest of the table. And from here, if we write our minterms, we can see that we have M1, M3, M4, M5, and M7. That's when we have a 1. So what we can say is that the function is equal to the sum of minterms, which is equal to M1, M3, M4, M5, and M7. Now, conversely, we could look at the product of Maxterms, and we know that's going to take place at these zeros. So we could also express f as being equal to the product of M0, where notice the lowercase and uppercase change, M2, and M6. And with that being said, you can see that the sum of minterms has 5 terms, the product of Maxterms has 3 terms. Either are valid and will get you your original function f, just in a different notation.